Okay, so we're gonna start with 2.9. This is 2.9. And we're gonna start with number 5. And our whole goal is to graph from factored form. And then eventually over here, down here, and a couple other ones, right? You're gonna get to the point where we're looking at this thing and then we're able to change it to factored form and then pull off the information that's really important, right? Okay, so let's just start here. Where did it go? Sorry, right here. Here. Okay, so here we are with negative x parentheses x plus 4. And then I was peeking at your work and it was really strong work. So I just kind of want to show off, like, look how beautiful it looks. Some of you are like, man, Ms. Johnson, we don't like really are horrible at drawing. Yes, annotating on a mouse is very difficult. So I'm just going to choose, I think, this one just because it's there. So the biggest things that I want you to recognize is this: when it's in factored form, some of this information pops out to you. Like it just comes, like it's there and available to you. So here's this person, they draw this out. Here's the vertex at -2, 4. The intercepts are at 0, 0, and -4, 0, 0, 0, and -4, 0. The y-intercept is the same as the x-intercept, which is 0, 0. That's great. So, and then you have this line of symmetry going through here. So there, you're gonna see a trend, and that's what I want you to focus on. Like, what trend do you see? Okay, so then I'm gonna go over here. Oops, over here? No, over here. Yeah, right here. So based on the examples, how can you tell, how can you use the quadratic form to find the line of symmetry, find the vertex, find the parabola, find the x-intercept, and the y-straps? Okay, so I'm going to answer this question after I go through a couple more of these, because I want this to be something that you figure out on your own and not me tell you, right? So now it's your turn. Try the strategy, factor each of these functions and use the strategy you found in problem 4 to find the vertex, blah, blah, blah. Okay. So the very first thing that they told you to do is find the factored form. So some of you were asking a question, Ms. Johnson, what does factored form mean again? So whenever I talk about factored form, I'm talking about parentheses, something, 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 and parentheses, something, 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 right? So this is what factored form looks like. So when it's in factored form, you get some of this information just by looking at it, okay? Okay, so here we go. Okay, so I already looked and a bunch of you already factored this. So I'm going to go peek through here and I see a bunch of people factoring stuff. Okay, so I'm just going to choose a random like this right here. Sure. So this person here has it in factored form. Now, Ms. Johnson, how did they factor this? So this was what we've been going over for the last couple days in 2.8, where you use your X, right? And then you fill in your box, right? So factored form, this guy here, hold on, let's do factored form here means the parentheses here and here for this rectangle. Okay, so if you ever forget, Ms. Johnson, what's factored form again? It's the outside of the rectangle. It's the outside of this rectangle. Very good. This person had x minus 4 and x plus 2. They graphed it, and then here's a bunch of information. So from your factored form, let's see, is their line of symmetry right? Check. Is their vertex right? Check. Their intercepts right? Check. And the y-intercept is also correct. Okay, so here's your job. Your job goes like this. Ready? Man, here, she wants me to factor this. Okay, which one of these things here are obvious in factored form? Which one of these things here are obvious in factored form? I'm going to erase all my stuff. Very good. These match these. You guys all see that? Do you see this -4 here? It's a 4. Do you see this +2 here? It's a -2. You'll understand why they are opposites later. I promise you will. But for right now, just know in factored form, they're telling me what my x-intercepts are. Very good. Very good. Very, very good. Very, very strong word. Okay. So, okay, Ms. Johnson, that's great. So what is this guy used for? So now look at this and figure out where he's useful here. Let me change colors. Purple. Sure. Hey, whoever's I'm using right now, I promise I'm not ruining yours. It's just, you know, I just need to write. So why is this guy useful? Where do you see him in all of this? Does anybody see this in any of this? Yeah, very good. Okay, this, someone says, hey, Ms. Johnson, it's the y-intercept. Okay, I'm going to just draw a line. Good. So when I give you this, you're like, ha, she gave me the y-intercept. When I give you this, you're like, ha, she gave me the x-intercept. Do you see the advantages of both of these? Okay, very good. And then obviously in vertex form, I'm giving you the vertex, right? Okay, so let's just go from there. So, okay, fine, Ms. Johnson, but how did you figure out the vertex or the line of symmetry? How did you figure out the vertex or the line of symmetry? What do you guys think? Did I give you those pieces of information, or are they completely hidden from you? Well, what do you know about your line of symmetry? What do you know about your line of symmetry? It goes through what? Yes, it goes through the vertex, but it also goes through the what? The middle, right? Very good. Thank you. So it goes through the middle. Very, very good. So if it goes through the middle, so let me just pretend. So you're saying, Ms. Johnson, I have my x-intercepts and I plotted them here and here. To find my line of symmetry, I just find the middle. Yes, it goes through the middle. So you want me to find the middle of 4 and -2? Yeah. And let's pretend you don't know how to do that. So you just guess and you say, does this look like the middle between 4 and -2? Does this look like the middle? And you're like, no, because that's 2 away here. And then it's 4 away. That's not the middle. And you're like, okay, fine. Is this the middle? And you're like, yeah, that looks like the middle. Because look, it's 3 away here and 3 away here. Very good. Okay, so all you have to do is find the middle. You all know how to find the middle between two numbers. I can give you a formula if you want, but that's just another thing that you have to remember. Just find the middle. So you want me to find the middle between 4 and -2, and that's my line of symmetry? Yes. So here it is at 1. So that's why this person put x is equal to 1. He's the middle. He's the middle. Everybody okay with that? Okay, fine, Ms. Johnson, but how do you find the vertex? Well, there's a couple different ways that you can find the vertex. One of the ways is by changing this and completing the square to get you in vertex form. If you don't want to do that, well, if you know your line of symmetry goes through the middle, including the vertex, if this is the x, see this guy's the x right here, right? Then if I know what the x is, I can plug in to find my y. So let me plug in really quick. So you're saying 1 minus 4. Well, that's -3. And then 1 plus 2. And that's +3. -3 times 3 is -9. Oh, Miss Johnson. And that's how you find all of these pieces. So your job was to look for the trend and the pattern to find all those things. So really quickly, just so that we're all on the same page. In terms of vertical stretch, also had a couple more people asking me about vertical stretch. Who remembers where my vertical stretch can be found? Where in the world can I find my vertical stretch? Very good. Okay, very good. A couple people said, Ms. Johnson, whoever's with the x squared, this number right here, right here, is going to tell you whether he's stretched or not. In this case, it's an invisible one, so there's no stretch. He's kind of what we would call average, normal, something along those lines. Does that make sense? So let's pretend that, let's say we go to over here. Yeah, this one. See this number here? He has a vertical stretch of 2. Now, some people call it -2. I don't care whether you call it -2 or +2. The negative he has a completely different job than the vertical stretch. So I don't consider him part of my vertical stretch. Let me ask you guys, what is this negative's job? What is his job? What is this negative's job? Yes, he makes the parabola face up or open down. So this one, he's going to open down. He's going to be a sad face, right? Versus, say, this guy, he's a happy face. That's all good. So does this one have a vertical stretch? Looking at this, does this have a vertical stretch? Yeah, it has a 2. Now, Miss Johnson, can you only find the vertical stretch in the standard form? I don't know. Look at the factored form. Does it have a vertical stretch? Look at this. Look, based on this, where do you see that vertical stretch? Yeah, he's still right in front. That 2 in front of the x squared. See, x times x is x squared. Yeah, he's still there. So no matter what, you should be able to do these now. So we've talked about how to graph from vertex form, and we've talked about how to graph from factored form. Now, some of you are going to be like, no, Ms. Johnson, I really, really like vertex form. That's great. Use vertex form. I'm never going to tell you, you have to graph it in this form. You have to. In fact, that's not going to, the questions I probably will ask is something like this. Pretend this is my question. Looking at the factored form, what things can you tell me about the graph of this function? And some of you are going to be like, oh, he's stretched. Oh, the x-intercepts are 4 and 2. Oh, the line of symmetry is smack in the middle of that. And now I can find my vertex. So some of you are going to be able to tell me a lot. When you look at standard form, what kind of things can you tell me about standard form? Very good, Jaylene. Yes, ma'am. Someone asked, Ms. Johnson, is a vertical stretch meaning it's a number other than 1? Yes, exactly. So if it was 1/2, it's a different kind of vertical stretch. Remember, we talked about him as being really, really wide, right? Yes. So for this one, this only really gives me my y-intercepts. I can't really tell what the vertex is. I haven't taught you this way. I can't really tell you what my x-intercepts are. I haven't told you how to do this. Okay. So with that being said, I'm going to go over a couple more of these slides so that you guys feel comfortable about what you're doing. Slide 6. Let me see. Let's look at, oh, you guys did this in a different way. Okay. So I'm just going to say for right now, let's see, does this actually work? Negative x squared minus x minus 5 is -6. Yeah, this is perfect. I will tell you right now, preference, I'm just going to tell you my preference. You do not have to change it at all. So if you have this as an answer, leave it alone. My preference as a mathematician, and maybe you'll understand why, I don't like when this guy's negative here. So the first thing that I actually did was I took out a negative and put him out in the front. So I went like this, x squared plus 6x plus 5. Does that make sense? So the very first thing I did was I factored out this negative. Ms. Johnson, you can do that? Yes, you can do that. Because this is still the same as this, is it not? Okay. And then you're like, oh, but Ms. Johnson, you're not going to get the same answer. Well, you kind of are. You just kind of have to look for it a little bit better. So if I factored this again, right, I can leave that negative parenthesis. I'd leave that negative outside my parentheses. And so I'm looking for 2 numbers that multiply to get to 5, but add to get to 6. And I'm like, oh, that has to be x plus 5, x plus 1, right? Okay. Can you tell me if this is, yeah, exactly. Is this the same as this? Look really carefully. Do you think this is the same as this, or are they completely different? Like, is this a $20 bill and this is $2? Because if they're both valued at 20, then we don't care, right? So do you all see this in here? So Miss Johnson, let me make it bigger. Can I make this bigger really quick? Yeah, let's make this bigger. Okay. So Miss Johnson, I see this x plus 5. It's the same as x plus 5. I see that. I see that. So what's throwing me off, Miss Johnson, is this negative right here and the x plus 1. Is that the same as this negative x minus 1? Are these two the same? The negative times the x plus 1 and the negative x minus 1. Are these the same or are these different? What do you guys think? Yeah, so these are the same. I'm going to prove to you really quickly. If I multiplied negative parentheses x plus 1 plus 1, can you distribute that for me? Can you distribute this for me? What would that be? What's negative times x? Very good, negative x, thank you. And what's negative times positive 1? What's negative times positive? Yeah, negative 1. So now do you see them as being the same or do you see them as being different? What do you think? Same or different? Very good. Yeah, now you see, you're like, oh, those are the same. Yeah, but they looked really different before, right? So this is just a preference, and this is what I do. You do not have to do this, but I tend to think of the x squared as always being positive. Thank you. I always tend to think of x squared being positive, and then I can factor in this negative if need be, right? So if you really wanted to rewrite this in a different way, you can rewrite this also as negative parentheses x plus 1, x plus 5. And you should see these as being the same. Does that make sense? So person who did this, I don't expect you to change it because your answer is perfect. But I want you to see one of the things in math that I would like you guys to all be able to do is look at something and say, oh, those are the same. They just look different. Think about like a $20 bill and two $10 bills, right? Or this is 4 or $5 bills. And this is a 10 and 2 5s. You guys always see all of these values are exactly the same. They just have different looks to them. Very good. So yeah, this one looks great. Perfect. Look at number 10 and then we'll call it a day after number 11. Let's see. I'm just picking random people here. Yes, we will do that together. So 2x squared, let's see, 2x squared minus 4x minus 6x by 12x 18. Yeah, this is perfect here. Whoever factored this is good. I like your x-intercepts here, 4 and 2, good. Your y-intercept looks right. Your 3, negative 2, I have to plug this in. So yes, 3 is smack between 2 and 4. And then I plug in 3 here. I get negative 1 times 1 is negative 1 times 2 is negative 2. Yeah, this whole thing here is perfect. Whoever did this is awesome. They even told me, hey, Ms. Johnson, it is facing up. And he's skinnier. They said vertical stretch is 2. So that he's just a bit skinnier. Very good. Very good. Very good. All right, let's do, someone said, Ms. Johnson, can we please do slide 11 together? So absolutely. I'm going to go on my iPad over here because I like to be able to draw neatly and everybody can understand what the heck I'm writing. Okay, so the very first thing that when we're doing this that I think about what do I want to do first is I want to get it in factored form because I like factored form. I'm doing number 7, right? I'm doing the right one. Oh, I'm not doing the right one. Number 11, number 8. Where is number 8? Here you are. Haha. Here we go. Okay. So the first thing that I'm going to do, I'm going to tell you again, I don't like this negative. So I'm going to factor out that negative first because it bugs me. He bugs me. Okay. So if you don't factor out a negative, that is completely great. So I'm going to go negative parentheses 2x squared plus 5x minus 3. Everybody okay with this? Okay. Because I'm doing that, I already know that that negative is going to live there. So I'm going to go negative parentheses as my answer. Okay. And then I'm going to use that the diamond method in array or the Xbox to figure this out. You guys can work with me as well. So here's my X. Here's my box. You guys remember where everything goes? Where does 2x squared go? Where does 2x squared go? Yeah, very good. It goes up here. Someone asked a question from earlier. I didn't catch it. So someone said, so when there is no number in front of x squared, the vertical stretch is 1. Yes, ma'am. So let's look at one of those just to make sure, like here, right? The vertical stretch for this one is going to be 1. Right? Very good. Okay. So already we know, you guys can already tell me, Ms. Johnson, this one has a vertical stretch of 2. You can write that down right now. Sure, I can do that. Write that there. So yes, the 2x squared goes in the top left, someone said. So this guy goes over here. Very good. Where does the 5x go? Where does the 5x go? Very good. Someone said, Ms. Johnson, the 5x goes at the bottom of your diamond or your X. Very good. Very good. Where does -3 go? Where does this -3 go? Yes, very good. Bottom right. Okay. I forgot. What goes up here? What goes up here? Yes, it's a times c. Now here's the question. Someone says, Ms. Johnson, am I ignoring that negative when I'm factoring? Yeah, because do you see that negative? It's that negative. I'm pretending he's not there. Very good. So yeah, I put -6x squared, rather, -6x squared. So then again, I'm trying to think of two numbers that multiply to get to 6, but add to get to 5. Yeah. Multiply to get to 6, but add to get to 5. And you're like, Ms. Johnson, there's two numbers. I know, but we have to be very specific. I want to get a -6. So 1 times 6, 2 times 3, but they add to get to 5. So that means one of them has to be negative because this guy's negative. So which one is it? 1 and 6, 2 and 3. Yeah, it's -1x plus 6x. Now, some of you are like, Ms. Johnson, how can it be 2 and 3? Not really, right? Because in order to get a -6, one of these would have to be negative. So if one of these are negative, then I can't get a positive 5x. Very good. Very, very good. You guys are all remembering. I love it. I love it. Okay, so then I put this over here. And then I ask myself that question, what's the greatest common factor here? Oh, it's not catching up to me. Sorry, I put 6x up here. Can you guys all imagine that? So what's the greatest common factor of 2x and 6x? Actually, in this case, it's 2x, right? Because there's a 2 in both and there's an x in both. Very good. So 2x times what gives me 2x squared? 2x times what gives me 2x squared? Very good. X. And then 2x times what gives me 6x? Very good. Plus 3, not 3x, just 3. And then x times what gives me negative 1x? Very good. That's minus 1. So there's my two factors, x plus 3 and x negative 1. And then negative 1 times positive 3 does give me negative 3. So there it goes. So I'm going to write my two factors out, 2x minus 1 and x plus 3. Okay. So, Miss Johnson, what do I do with my intercepts? Yeah, this one's a little funny, right? So if we actually graph this one out, you'll understand a little bit more why that is. Let me go grab this guy. So I'm going to graph this really quick, and then I want you to focus on your intercepts. Squared minus 5x plus 3. Okay, this intercept made sense at negative 3, right? Because one of our factors was negative 3, right? That makes sense. This one is 1/2. This one is 1/2. So wait, what, Ms. Johnson? So one of them was 1/2. So 1/2 comma 0. And the other one was negative 3 comma 0. Where does that, look at this. Where does that 1/2 come from? Where does that 1/2 come from? The negative 3 makes sense, right? Yeah, the 1/2 comes from, can you guys all do me a favor? Can you plug 1/2 into there? What's half of 2? 1. Good. What's 1 minus 1? 0. So that's the important part, that it made it a 0. Okay. So remember how earlier I told you this is why they're opposites. It's more because it makes it a 0. It makes this whole thing be a 0. Very good. And if you can, let me see, and then smack in between negative 3 and 1/2. I'm actually going to look at my picture, my vertex. Ooh, my vertex is weird. It's negative 1.25 and 6.125. Lots of fractions here. And then there's your line of symmetry. The whole point of this one, I know this one was tough. The whole point of this one is, can you still apply all of the things that you learned? And the answer is yeah. Okay, so smack in between 1/2 and negative 3 is that negative 1.25. We won't write this down right now. We'll write it later. But where's your y-intercept? Where is my y-intercept? Where is my y-intercept? Very good. My y-intercept is 0,3. Someone says, Ms. Johnson, I saw that in the beginning. Exactly. Good job. So, Ms. Johnson, are you going to give us a problem like this on our quiz? I'm not really interested in you showing me that you know how to deal with decimals and fractions. I'm really interested in you showing me and can explain to me why you know that 1/2 comma 0 is an x-intercept. Okay, very good work here. So, so moral of the story here is you should be able to understand where factored form helps you fill this out, how standard form helps you fill this out. Okay, good job.